Hello friends, this video on acid and base part 12 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 11. We know what is dilution because we know we have learned concentrated and diluted acid and concentrated and diluted base also. So we generally dilute the acid or base. The process of dilution is highly exothermic because it gives out a lot of heat. You put acid in water or base in water, it gives a lot of heat, right? So extra care has to be taken. So what we do is, when we do this, we stir it properly and we slowly add acid or base to the water. So you keep this water here and then slowly, little by little you add acid or base and you keep stirring it so that you don't get very high heat, because this is the exothermic process. If you add, let's suppose, 1 liter of water and 1 liter of acid, it will generate huge heat. It may burn your hand, it may burn the container also if it's a plastic container. So it's advisable that you add acid or base to the water very slowly and you should do a constant stirring, right? So the caution is, water is added to concentrated acid, you may get burns or heat will come out. So the glass may also break because of the excessive local heating. So it's good that you do it slowly. So the process of dilution is like this: you take this water and slowly, because the two thing is slowly and stirring. So you have to slowly add acid and constantly stir, right? Constant stirring and add slow. Two mantra for process of dilution. We'll take some activity, we'll take some 10 ml of water in beaker and we'll draw few H2SO4, very few H2SO4, and we'll take some concentrated H2SO4 to make it dilute, very few, and then we'll touch the base of water. We'll see that it is hot. That means this exothermic reaction. We have explained in the last chapter that exothermic reaction is those reaction which gives heat. So if you don't know these things, exothermic and endothermic reaction, you can watch the last chapter video. Also, the last chapter we have done the balancing equations. We have done more of those in the last chapter. So if you have doubt in that, you can watch the previous video in that case. The next question is, why is hydrochloric acid, nitric acid show acidic character in aqueous solution, while the compound like alcohol, glucose, they don't show acidic property? The reason here is, again, for acidic property you need H plus, right? So you take HCl and NO3, anything you take, nitric acid. These guys, when you put in water, this guy gives H plus ions. This guy gives H plus ions, and this H plus ion is responsible for the acidic nature of the acid. But if you see, glucose and alcohol, they have hydrogen, but when you put this in water, they don't dissociate. No dissociation, right? Because they have hydrogen molecules in this, but when you put in water, they don't dissociate because they are binded with a covalent bond. They are not ionic bond. Covalent bond a little stronger, ionic bond a little weaker. So we'll explain again all these things in the class 11th, why they don't break. Just for now, you understand this: hydrochloric acid, nitric acid, you put in water, they break actually to get H plus ions, but glucose and alcohol, when you put in water, since they have hydrogen ions, but they are very strongly bonded with covalent bond and they don't dissociate. They don't break into H plus ions. So even though they have hydrogen, they don't give H plus ions. They don't give H plus ions. Since they don't have H plus ions, they are not acidic in nature. So anything for it to be acidic, it should have H plus ion. Please note, we are not talking about H, we are talking about H plus, right? So it should have H plus. So water, when added to nitric acid or hydrochloric acid, it gives H plus ions, but when water is added to glucose or alcohol, it doesn't give H plus ions. While diluting an acid, why it is recommended that acid should be added to water and not water to acid? Why? Because this whole thing is an exothermic process. It gives lot of heat, right? So if you have a huge acid, let's suppose 1 liter, and you put some water in this, it may burn, it may burst, right? So we should avoid this, and we take water, and then in that we put acid slowly, and we stir, right? This is all because this reaction, acid plus water, is highly exothermic. It gives huge heat, right? That's the reason why we don't recommend that. How is the concentration of hydronium ions, affected when a solution of an acid is diluted? Obviously, it will be less. So you can say that per unit volume, if you talk per unit volume, H hydronium ions will decrease. But the total hydronium ion will be same. So, for example, you have, let's suppose it has 100 hydronium ions, right? I'm just guessing. Okay, let's suppose 100 hydronium ions, some acid you have taken. Now you're putting water in that. So the number of hydronium ion will be same, but let's suppose this was 10 ml, and now in this you have added 90 ml water. Now the status has changed. Earlier it was 100 hydronium ion in 10 ml of water. Now it is 100 hydronium ion in 10 plus 90, that is 100 ml of water, right? So it is like 10 ions per ml, and this is 1 ion per ml. So per volume, if you see per unit volume, it is less. So it becomes weak actually, because per unit volume the ions concentration is less. But the total ions are same. Correct? That's why the strength is poor. Strength also goes down. Why? Because per unit volume the hydronium ions are lesser, so it is of less strength. Why is the concentration of hydroxide ion affected when excess base is dissolved in the solution of sodium hydroxide? How? So in this case, I'm saying that I have this OH minus ion. Excess base is dissolved. We have some base. Already we have some base, right? So we have some base. Let's suppose we have some base OH minus some base. In that we are adding sodium hydroxide. So what I'm doing is I'm pumping in more and more hydroxide ions, and thus you can say that the strength of OH minus here in this case is increasing. Why? Because I'm pumping in more hydroxide ions. It's the same thing I am adding to water. I am not pumping in hydroxide ions. In this case, my concentration will go down. But in this case, I am pumping in more hydroxide ions. Since I am pumping in more and more hydroxide ions, the strength of hydroxide ion is increasing. In the last example, we have pumped in more water in acid. So the strength of acid goes down because the hydronium ion concentration was less per unit volume. In this case, I am adding more base to a basic solution. It was base already, I am adding more base, so it becomes all the more basic. Correct? Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.